Alright guys, so this is the second video on this homework. We did cover on the previous video all of these questions like 4, 6. So I want to do a couple more. I apologize for this sexy voice I have right here. I'm still sick. But anyway, I do want to talk about special cases. Now on our notes, we had these two situations that are special cases. And let's read this right here. If you're solving an equation and you end up with something impossible like 0 equals 3, then your answer is no solution. Okay? So if we look at this example right here, 2 times 3, that's 6x. 2 times negative 4, that's negative 8. Bring down the minus 5x. And then you continue to combine like terms. 6 and minus 5, that's a positive 1, and we're talking about x's. Bring down the minus 8, bring down the equal sign, and then on the right side, combine like terms. 3x, take away 2x, that is 1x. Bring down the plus 9, and then now you want to move on to your goal of getting x by itself on one side. And the problem is you have x's on both sides, so of course you want to get rid of one of them. So we're going to subtract this 1x right here. But when you subtract it over here, it also disappears. So what do you have left? Negative 8 equals 9. That, ladies and gentlemen, is impossible. Negative 8 will never equal 9. So what do we say? We say no, as in no solution. Okay, that's a special case right there. Now, sometimes you're going to be solving an equation and you end up with something that's always true, like 3 equals 3, or 0 equals 0, or 5 equals 5. Then your answer is all real numbers. So again, when it's impossible, you say no. When it's always true, you say all real numbers. Okay. So I might as well walk through this one as well. 2 times 3x, 6x. 2 times negative 4, negative 8. Bring down the minus 5x. Combine like terms. 6 minus 5 is positive 1. Bring down the minus 8. Bring down the equal sign. Combine the 3x with the negative 2x, that is positive 1x. Bring down the minus 8. And as you can see, you have the identical left side, identical to the right side. So at this point, you could just stop. But even if you didn't see it, and you're like, okay, I need to get x's to one side. Okay, so if you get rid of this 1x, and what you do to one side, you do to the other, you do end up with something that's always true. Negative 8 equals negative 8. That's always true. So if it's always true, you say all real numbers. An abbreviation for that would be x equals that weird looking r, all real numbers. Okay. What that means is that you could plug in any number for x. You could plug in a 5 right here, a 5 right there, a 5 right there, and a 5 right there, and it'll give you a true statement. You could even plug in any real number, like pi, even if it's irrational. Pi right here, pi right there, pi right there, pi right there. It'll give you a true statement. Anyways, let's move back to our worksheet. Let's do a couple of special case problems on our worksheet. Number 8 will be a special case problem. Again, if you want to start solving this thing, you're supposed to think, I need to simplify first. What does simplify mean? Distributive property or combining like terms. So if you look at the left side, there is no distributive property, there is no combining like terms. If you look at the right side, again, it's already simplified. So we move on to step 2, getting x by itself on one side, but in this case, y's. So I'm going to get rid of the minus 6y by doing plus 6y. What I do to one side, I do to the other, plus 6y. It will cancel out both. What do we have left? We have a negative 3 equaling a positive 3. We know that that is impossible, so we say no solution. Let's try another special case. Let's try a different one. Number 11 is a special case problem. So again, you're supposed to see if you could simplify the left side. There is no distributive property. There is no combining like terms. On the right side, we do have distributive property. So let's go 4 times 3, that's 12. 4 times 2, that's 8 with a q, and it is positive. So I've simplified both sides. Let me bring down the left side. As you can see, they are identical. There's an 8q and an 8q. There's a positive 12. There's a positive 12. So at this point, I could already say x equals all real numbers. Okay? Well, in this case, it's q. I'm sorry. Let me change that x to a q. Q equals all real numbers. Even if you didn't see it right off the bat right here, even if you kept solving and you're like, okay, I want to get q by itself on one side. So you would subtract 8q. You would subtract 8q, and then at this point, the q's disappear and you have 12 equals 12. That's always true. So that's where you say all real numbers. So it's up to you if you want to write this answer or if you want to write it like that. Now let's might as well take advantage of the time we have on this video, and let's do a couple that require getting rid of fractions, huh? Let's look at the hardest one here, number 22. So remember, you could get rid of any fraction you want as long as you multiply everything by the denominator of the fraction that you want to get rid of. So if you chose to get rid of the 1/2, you'd have to multiply everything by 2. Put a 2 up here, it'll cancel. But if you put a 2 up here, it won't completely cancel the 8. It'll only reduce the 8. So instead of just going with the first denominator you see, let's find our LCD, our lowest common denominator. Okay? The question is, could you convert 8 to become a 2? No, 8 times 1 is 8, right? So you can't change the 8 to become a 2, but you could change the 2 to become an 8. So 8's already 8. 2 could become an 8. So the LCD will be 8. So if you multiply everything by the LCD, you'll be able to get rid of all the fractions at once. So put a times 8, times 8, times 8, times 8. And yes, 8 divided by 2, that ends up being 4. And of course, the 4 is on top. 8 over 8 is 1, cancels out. 8 over 8 is 1, cancels out. 8 over 2 is 4. So what do we have left? An equation with no fractions. We have a 4 up here minus 5x. Bring down the equal sign. Equals 7x plus, now here's the only interesting part, 4 times 7, that is 28. So there's your new equation that has variables on both sides. Now let's get x by itself on one side. So you ask yourself, where's the x at? Is it on the left side or is it on the right side? Hey, it's on both. You don't want it on both, so let's get rid of one of them, right? I am going to move the minus 5x. I want to get rid of it on the left side. What I do to one side, I do to the other. So if I added 5x over here, I need to add 5x over here. Plus 5x. So what do we have left on this equation? We have the 4 that came down. The equal sign comes down. 4 equals 7 plus 5 is 12. And we are talking about x's plus 28. That comes down as well. So now we want to get x by itself. X is on the right side of this equal sign. I need to get it by itself on this right side. I don't want the 12. I don't want the 28. We get rid of the 28 first. What I do to one side, I do to the other side. What do I have left? I need more space. Okay, what do I have left? I have 4, take away 28. If I have $4 and owe 28, I will still owe 24. Bring down the equal sign, bring down the 12 with the x. I need to get rid of that 12, but we need to recognize that it says 12 times x. So to get rid of the multiplication of 12, I would have to divide by 12. What I do to one side, I do to the other side. So my final answer is x equals -2. I wouldn't leave it like that. I would write it with the x on the left side and the -2 on the right side. So I think you guys will be able to handle all of these. Good luck. As a matter of fact, I want to do one more because I see that there's fractions here, but there's many ways of doing these different problems. So one option is to multiply everything by 3, this times 3, this times 3, that times 3. Or you could move the minus 6 over to that side right now. I mean, because you could get rid of the minus 6 easily by doing the opposite. Plus 6, plus 6. That'll cancel out. And you're going to have a new equation that says 2/3 v equals 12 minus 2/3 v. And then you could multiply everything by 3. This by 3, this by 3, this by 3. And you will get 2v equals 3 times 12 is 36. And the 3 and the 3 cancel. So you're going to have a minus 2v left over. Now you want to get v by itself on one side. And of course you have v's on both sides here. You don't want it on both sides. So let's get rid of one of them. Now, it would not make sense for me to go minus 2v here and move it this way, because then you would have everything on one side, and the goal is to get v by itself on one side. So it'll be easier to get rid of this minus 2v by doing the opposite, plus 2v. That'll cancel it out. What you do to one side, you do to the other. So now you will have 4v equaling 36. And your final step would be to divide by 4, which means v equals 9. Is that the only way to do it? Absolutely not. Let me show you a different way. You could have multiplied everything right from the start by 3, by 3, by 3, everything by 3. You would have ended up with 2v minus 18 equals 18 minus 2v. Let's move the v's to one side. Plus 2v, plus 2v. I'll have 2 plus 2, which is 4 v's, minus 18 equals 18. And then add 18, add 18. You will have 4v equaling 36. Once again, that's 4 times v, which means to get rid of the multiplication of 4, you're going to divide by 4. And again, you get v equals 9. Of course, there's other ways of doing it, but I think this video has already been long enough. The answers are in the back, by the way, back of your worksheet.